Okay, ambitious solution, solve the problem of fake news, right? Just with them out. Well, so couple perfunctories. First thing to say is it was so awesome to follow Fran and Joan for those last two talks because it makes my job so easy now. Number one, everything that Fran talked about, especially with like COTA and the V2 version of COTA, that's the stuff, that's another example of taking these very techniques and applying it to solve real problems at Uber. We're hiring. So Fran will be, along with myself, will be Washington for you out in the lobby during lunch. Second thing to say is while sometimes I get the question, what does this have to do with Uber? That's what it has to do with Uber. Also, we're hiring. This is actually a research project that we started about 2016-ish for completely coincidental reasons to think about how to use all of these latest techniques to approach the fake news problem. And so one big takeaway that I want to drive home in the next 25 minutes is that actually, machine learning can solve a lot of problems. It can't solve every problem, and so sort of switching or looking at sideways what kind of problem you're trying to solve and what can be solved with all of these beautiful and amazing techniques that I couldn't have dreamed of us having in 2018 can really turn an intractable problem into a tractable problem. And I have All right, so I'm going to spend a little bit of time talking about what I mean by that, by turning a tractable problem or intractable problem into a tractable problem. Then I'm going to go through what's usually like the really fun stuff, like talking about all the different techniques that have come out in the last 5 years that have cracked open the world of natural language processing. You've seen like 2 good talks on that already, so I'll go as quickly. I'll read the room and see if you're bored seeing it for a third time, and then we can go in quickly. And then for the third one, we might have time to actually test out the algorithm. And I have some, just in case we have technical difficulties, I have some examples of things that, often in the last 5 minutes people just yell out, well, what about this one? Is that fake? Can you figure it out? And so we can test those in the last 5 minutes. All right, so what is the fake news problem? It is, at least 2 years ago, and this is something that Facebook and Twitter have been trying to solve, it's very difficult when you start turning it into a truth detection problem. Detecting the truth is a very difficult problem. It's something that humans have been trying to do since we learned how to talk around 50,000 years ago. And machines are probably not going to solve that problem when we're talking about new information. You can do factoid extraction and compare it to a knowledge graph that you have in a database. But when you're talking about news is new facts. And so that's the job of journalists, is to go out, find those new facts that are out in the world, pull them in, and add them to our shared knowledge of the world. So treating the fake news problem, or at least solving the fake news problem with machine learning, let's do truth detection, let's create a magic deep learning truth detector, is going to run you into a lot of trouble. And we've seen that over the last couple of years, people trying to do this and not having a lot of success. Facebook has really shifted towards more of a crowdsourcing all of the fact-checking organizations that are out there in the world, and that gets you a little bit of scalability, but the problem is that getting to the truth is a hard job, and so it's hard to scale fact-checking. So when we first started thinking about how to solve this problem, or how to contribute to a part of the solution of this problem, we started thinking about this well-studied phenomenon in psychology, which is the more emotionally engaged you are with what you read, the worse an impact it has on your cognitive function. The more you care about it, the more afraid you are because of it, the more angry you are, the more of a sense of urgency that you have, the less equipped you are to think about the thing that you are reading. And then these slides will be shared. There's a lot of review articles. That one's from like a year ago. I'm sure there's more now. This is a very well-documented phenomenon. And so the hypothesis was maybe, or wait, Sorry, I forgot. I switched up the slides a little bit. Let me tell a joke. All right. So this is, thank you to, I told this joke so many times, IBM did a cartoon of it. So this is the cartoon. So imagine you think, this is a horrible defect in humans, right? The more we care about what we read or what we're learning about or what we're thinking about, the worse we are in using reason to think about those facts, right? And so I'm going to make a case for why that's okay. Actually, it's advantageous sometimes. And you got to do a thought experiment. This is, imagine two cavemen are walking into a cave to get a drink. And they see a bear, or a shadow of a bear. I don't know, is it a bear? Kind of looks shadowy like a bear. And the first one is going to use all of his brain power. He's going to scrutinize his hypotheses. He's going to interrogate every assumption. And only then is he going to draw the conclusion. There's a bear in the back of the cave. Well, the second one gets the hell out of there. And the moral of the story is, which one do you think survived to become your ancestor? Right? So in some sort of very gross evolutionary process, if you're the kind of person that gets convinced by evolutionary arguments, by cute cartoons, there is reason why it's been advantageous for us not to think about things when danger is involved. That's something that the hypothesis goes, we thought that fake news propagators are taking advantage of. Maybe that's something, that's a hidden signal that we see, whether or not they're saying the truth or not saying the truth. If they're trying to engage emotionally in a way that doesn't let you, that doesn't make the space for you to think about the evidence yourself and come up with your own conclusions about what's true or not true, maybe that's a good way to kind of come at it sideways and detect if somebody's doing fake news. So that's Mary Poppins. This is the classification exercise that we're doing. We want to detect if something is about credible information sharing or if it's more about emotional manipulation. All right, philosophy, motivation over. Now let's just do a quick review of everything that you've seen in the last 50 minutes, all the different NLP techniques that have changed the way we work with text. It all started with this, word2vec. I'm sure we all know what word2vec is. You look at, you solve a simple problem, it's fill in the blank. You get a single layer embedding to fill in that blank. I did philosophy in undergrad. The Uber NLP repo is going to be open sourced, I think, in like a month. It's called Ludwig, after Wittgenstein. The meaning of a word is all the words around it. That's word2vec, right? This is like scientific proof that Wittgenstein was right. So this was really cool. This is Chris Moody's GIF about king minus man plus woman equals queen. Once you can vectorize these words, they start to pick up semantic significance. And that was just the beginning. There's been a lot of word-level embeddings. There was Elmo and Bert and all the Sesame Street characters that have been coming out of Google in the last couple years for embedding more at the sentence level. And that has changed what we can do with text. So it's talking about doc2vec. There's naive doc2vec. We could just add up the words and then take the average or take the L2 norm, and that worked really well in 2013. You can do paragraph matrices. So this is figuring out like your context vector, and this sort of assumes that there's some hidden context, some hidden encoding of the paragraph itself. And so first you learn the words, and then you backprop through to this paragraph vector to learn that paragraph vector, and that gets you some pretty good signal also. Modern techniques, unless all you need is attention, use recurrent neural networks. In particular, they use LSTMs. So LSTMs are, and it really depends on, attention is not all you need in every context, and in particular in this context, it's not all you need. They are really good at managing all of the different linguistic structure that happens as we are going through a sentence. We have all sorts of things like relative clauses and adjectives and adverbs that are modifying things, and we keep track of that cell state in order to understand when we need to pay attention to something, when we don't need to pay attention to something. You can string these together, usually with natural language. It's actually 2 layers is usually the most you need for these, but you can have the hidden layer go up into another layer, and then it could even go up to another layer. And if you think about it, when time you get to the end, if you step word by word by word by word to the end of the sentence, in a way, that last vector encoding, depending on what kind of signal you're training it to see at the end, is an encoding of the entire sentence, of all the words in order and how they are related to one another. And if you have the right objective that you're then backpropping through, it'll hopefully capture that. Doing it bidirectional, so Joan talked about bidirectional LSTMs. That's just, you let the algorithm read it front to back, you let it read it back to front, then you concatenate the two, and now you have sort of a full picture of the whole story, the whole sentence in both directions. This is really good for novel text generation, if that's what you want to do. It's really good for translation, if you want to translate. So you encode the sentence in the English sentence, for instance, and then you decode it in German. You unravel it in German, and you learn all the way back from the German back to the English. It's really good to it's really good for text summarization, in particular, as we saw in the last talk, using something called attention mechanisms. You can do abstractive text summarization. So what does this look like? You pull out the end-to-end vector. You have the bidirectional LSTM. You have the end of the sentence when I read from back to front, the end of the sentence when I went from front to back. You concatenate those two, and now you have your principal one. So that's the H vector there that captures the whole sentence. But now you want to start using attention. You want to say, in particular, if you're doing summarization, or if, in our case, there are key things that you're trying to detect, things that might be suspect in the article, then you might want to pull those out, and you might want to know, what should I be paying attention to in that sentence? What words are going to be the emotionally engaging words that are going to try and suppress my cognitive function? What sentences are the most emotionally engaging to suppress my cognitive function? And that's where you want an attention mechanism. And this attention mechanism, there are lots of different techniques. I can go into a lot more detail because everybody here is so smart, and you're all practitioners, and plus half of the attention mechanism stuff was talked about in the last talk. So what we do is we look at the comparison of each of the sentences or words as you go through that sentence. It's a bidirectional LSTM. So if you're going front to back, and then you're going back to front, and you look at the concatenation there, you've sort of got a picture of each of these output hidden layers is going to have a picture of the sentence from like pivoting around that individual word. And so you can ask the question, which one of these is most relevant compared to some other sort of fixed point or external measurement of the capturing of this importance of the encoding of the sentence. There's a lot of different mechanisms for that. First of all, how do you compare? You can compare by having a full matrix. You can do a dot product. If you learn the full matrix, including the off diagonals of 2 vector comparisons, that actually tends to do better. So now you're learning what's important there. You can also, there's a question of what's your relevant sentence. The standard way to do that is this H vector. So this encoding of the entire sentence when you went from front to back, and the entire sentence when you went from back to front. It turns out, at least for our purposes, and I could talk about this a little bit more in a moment, doing something that's akin more to like a max pooling ends up getting a lot better results for our use case. So if you compare it to kind of like a max pool of all of the words along the sentences as you pivot through, you end up getting much better results, again, around like 2 or 3% in F1, sometimes better depending on the classifier. So that's it, right? There's one thing I didn't mention. So it is a hierarchical structure. You don't want to just encode the entire paragraph or the entire article of hundreds of words all in one go. What you want to do is there's a hierarchical structure to the way we phrase our articles. So first you go from words to sentences that are in order. Then you go from sentences to paragraphs in order. Then you go from paragraphs in order to articles. And all along, you're paying attention to what are the most important words in the sentences, what are the most important sentences in the paragraphs, what are the most important paragraphs in the article. And you roll that up, you get a context vector, you get an encoding of the entire class, and now it's just about figuring out the right objective in order to train that model to pay attention to the right things. And that's what we did. So remember, this is our target. We want to tell the difference between articles that are likely to be about credible information sharing and articles that are about emotional manipulation. And so we started with a couple words about the data. We started with URL-based, but URL-based, even if you've got like Breitbart or Infowars or for people on the other side of the room, Huffington Post, none of these sources are going to be 100% of any label, right? We picked 6 labels based on what people have been looking at as the different kinds of classes of fakeness or categories of fakeness that you could have. Journalism and wiki, those are good ones. There's opinion, there's satire, there's sensational, and there's agenda-driven, right? Is there an agenda that is trying to push you to adopt, regardless of whether or not the facts are there? And so we ended up taking all of these URLs. There's a lot of public consensus about different sites that, or domains, that is to say, that have these sorts of labels on them. And then we did a process which we've been calling reverse bootstrapping. Bootstrapping is you have too few labels, and then you sort of train a model to increase your training set, right? Reverse bootstrapping is you have a lot of labels, but they're kind of crummy, right? They're noisy. Maybe only 70% of them are accurate. And so you take a curation process, you bucket them up into a sequence of segregated buckets, and you build one classifier on the noisy data. Then you pull that out, and you use it to curate your second bucket, and then that second bucket you pull out the ambiguous cases. So now you have a lower entropy version in that second bucket, and you train a new classifier fresh on that, and you iterate until you start to get convergence in the way your model is scoring what articles are clear ones, what articles are clear zeros, and what articles are ambiguous. And of course, like bootstrapping, you can kind of catch an edge and magnify an error in your data. That can happen, so you need to hold out data sets that are your golden data sets in order to make sure that you're tracking along in the right direction. Oh, we don't have time. Awesome. Okay, so maybe I'll do a couple slides, because these are my favorite, of like people raising their hand and being like, "No, you can't figure that out." And then we can like have people yell out their favorite fake news websites and check them. So this one came out a couple weeks ago. This was pretty interesting. AI won't solve the fake news problem, and the thesis that they have, I agree, because AI solving, this is sort of like what I started with. AI solving, or machine learning, deep learning, solving the problem of truth detection and figuring out all the subtle context that goes into being an automated fact checker. That's a very difficult problem. So they have this example from the Boy Scouts. This is a World Net Daily, which I think is I think that's one of the, like it's an alternative site for Infowars guy. Boy Scouts have decided to accept people who identify as gay and lesbian among their ranks, and girls are welcome now too into the iconic organization which has renamed itself Scouts BSA. So what's next? A mandate that condoms be made available to all participants of its global gathering. And then they go in the rest of the article into all the subtleties of understanding whether or not this is true or false. But determining how this article went afoul is subtle business beyond the dreams of even the best current AI. Not so fast. So we labeled the article, we labeled the AI, the Faker Fact AI algorithm, Walt, after Walter Cronkite, because we want to bring us back to the world where your sources of news are trusted and credible and have been built on years of developing that credibility. So Walt says this one grabs your attention, but other articles are probably better to get just the facts. Actually, Walt thinks that about the opinion, the op-ed too, but op-eds are supposed to get high opinion. And actually, remember, we have attention mechanisms in there. So not only is it giving an overall score, it's also pulling out which sentences the algorithm is paying the most attention to as it's propagating up that encoding of the article. And in fact, 3 of the 4 sentences that they quote in this article, this middle part here, this part right here, are actually what Walt paid attention to. So while understanding the subtlety of why those sentences were not accurate, hard. But moral of the story, figuring out that there's a hidden agenda here, that there is something that they're trying to manipulate the reader into adopting in the way they presented the facts or the ostensible facts. That's a lot easier to detect with machine learning. A couple other ones. I just was really proud of understanding that Fear and Loathing is a little bit satire. I love Hunter S. Thompson. By the way, just because you have these, so I eat ice cream. I love ice cream, and diabetic. So it's not good for me. And knowing the nutrition facts about ice cream, even when I eat it, is important, right? So read the self-soothing right-wing or left-wing or satirical, everything you want. What this is aimed at doing, if there is a use case, the use case is to give you information about when it's a little bit too sugary or when it's more about the nutrition. And the last one, this happened like a couple weeks ago. Someone was like, well, yeah, but what if it really is sensational, like when Kennedy got shot? So I pulled up the archive there, and we scored it, and that got journalism too, which I found awesome. Okay, that's it. So we can do a little bit of, I pulled out the favorites. Does anybody have a favorite fake news site they want to yell out? Breitbart? I knew it. So there's like a Chrome extension. Anybody can play with it and see what, give me feedback, just email me feedback. Yeah, Breitbart doesn't always do so good. And it's, the attention mechanism tends to pull out things. You can sort of understand why that is. And in fact, if you look at right now it's only displaying, we should push this live within any day now, where you can actually see the attention sentences. We're not going to display the ones that are why it's not opinion, because double negatives can be confusing. But actually, if you look in the results, so it got a 0 on the journalism score, and these are the reasons why. And we got lots of different experiments. So the very brilliant postdocs and graduate students who have contributed to this project push new models all the time, and then we see what how they're performing. We got to be fair and balanced here. So let's check Huffington Post's opinion about Amazon. That's sort of like a double whammy here in this crowd. And so Huffington Post does not like the Amazon HQ2 times 2 thing. So so Bezos already owns homes in both cities and so forth. I mean, presumably he owns a home in every city, right? Let's see what UK. Uh-oh. See, that's what happens when you do a live demo. Yeah, Wall Street Journal always changes their HTML. I'm very comfortable as data scientist. I'm crap when it comes to scraping. This might be better. All right, so that's journalism. You can see. Oh well, it won't show why because of. Oh well, actually, we can see in the dev mode. So these are the sorts of sentences that it found especially journalistic. Any other preferences? CNN. That's CNN, MSNBC, and Fox News. Those are subtle because they're not. Sometimes the articles are journalism and they should count as journalism. so there needs to be, sorry. You can all read and see who reads faster, you or Walt. Yeah, and that counts as journalism. We can check Fox. I'm hearing something. Amazon rewards. What do we think? Do you want to read it while Walt reads it? Walt doesn't say it's wrong. Okay, I'm probably out of time. I got a couple minutes left. I'm gonna be sticking around during the lunch, so we can chit chat then. Again, Uber, we're hiring, and thank you.